And we begin. All right, section 1, and we're talking about logic. So let's start talking about just definitions of things. So a statement. A statement is represented by a capital letter like R or S, and it represents something like it is raining, it is sunny. So it's either true or it's false. All right, this mathematical statement right here is actually the statement x is less than 4 or x is equal to 4. This math statement right here is actually an and statement. X is greater than or equal to 1 and x is less than or equal to 5. So we're going to have we're going to be making a lot of truth tables with statements. Got that, didn't spell that wrong, right? Or combinations of statements, okay? So let's start by talking with lots of details, lots of definitions. So a negation. A negation is denoted by this little thing called a tilde, like that. And so if you wanted to say P is the statement, x is less than or equal to 4, then not P, the negation of this statement would be x is bigger than 4, right? Not this would be this. Okay, so let's make a truth table. So how do you make a truth table? So if I just have one item, like a P, I'm going to make this table, and I'm going to list below P the options. So we have a true, and we have a false. All right, so that's the options for P. Then what happens if I negate P and negate the true? I get a false. If I negate the false, I get a true. So this is the truth table for negation. Okay, so conjunction or and is denoted by this, like the upside down triangle here. So this statement here can be rewritten as these two statements, right? So if I had this statement P and I had this statement Q, right, x is bigger than or equal to 1, and the Q would be x is less than or equal to 5, then P and Q, the conjunction, would be this combined. All right, so let's make a truth table for these two statements, P and Q. All right, so I'm going to try to give you some guidelines of what will help you to make it easier to make sure you get all of the options. So for P and Q, I've got true and false for each of them, right? So I'm going to suggest that the first column we use true, true, false, false. For the second column, true, false, true, false. And in that way, I get all possible options of how to join together P and Q with trues and falses. All right, so P and Q, so true and true is true. So true and false is an actual and statement. Sometimes we use the word but it is the word and. So true and false. So false rules, so it takes away the true. False and true, this is going to be false also, and false is going to be false. So notice the only time I get true out of a P and a Q is if both of them are true. So that's just a quality of the and statement. All right, so now let's go to the or statement. So the or statement, or disjunction. So again, I'm going to make my truth table. So that's what this is, right? This is called a truth table. So P, Q, lots of new words, right? So this is going to be P or Q. So again, I'm going to encourage you true, true, false, false, and then true, false, true, false. So this gives me all combinations. So by definition, we're saying P or Q. And so true or true gives me a true. So what I'm looking for to see if there is a true. True or false, that's a true, because I have one true. False or true, yes, I have a true. False or false, nope, I don't have a true. So false or false is false. All right, so let's go on to conditional. So this is one that is denoted by this arrow. So you need to get to know these words, right? So conjunction, disjunction, negation, these are the biggies, right? Negation, conjunction is like and, Disjunction is like or. Now conditional has this arrow, and it's a really powerful statement. So this is what I'm going to suggest you use to kind of use to think about it. If I show up on Monday morning, then I will get the job. So if this, then this. If P, then Q. Or P implies Q. Or P is sufficient for Q. Or Q is necessary for P. All of these are the conditional statement, and it's really powerful. All right, so let's make up our truth table. So again, since I just have two, P and Q, I'd suggest you start with true, true, false, false, and then make this true, false, true, false. Again, what this does is it gives me all the different situations of trues and falses between the P and the Q. Okay, so now this, if P, then Q. That's how I'm going to say it. If P, then Q. So I'm going to even kind of go through this logic here. If I show up on Monday, then I get the job. There it is. It happened. So if I show up on Monday, true, then I get the job. True, because that's how the situation works, right? So how about this? If I show up on Monday, then I don't get the job, right? This is false. If I show up on Monday, then I don't get the job. No, that's not how it works. So that's false. If I show up on Monday, then I'm supposed to get the job. That's how it's supposed to work, right? Okay. So these two here are, they're going to be vacuously true. Whoops, true. Okay, so let me kind of go through the logic here. If I don't show up on Monday, then I get the job. Well, this happens to be true because your uncle owns the business. If I don't show up on Monday, then I get the job. All right. How about this one? If I don't show up on Monday, then I don't get the job. Yeah, that's kind of how it works. It's a little bit of logic, but these two are actually called vacuously true. All right, I'm going to stop here. No, I'll do one more. Okay, I'll finish off with the definition. So biconditional. So this is twice as powerful as the conditional. So this is like saying if and only if, right? So let's make a truth statement or a truth table for this biconditional, PQ. All right, so again, true, true, false, false, true, false, true, false. Okay, so P, if and only if Q. So true and true are both true, so that's good. True and false, no, they're not the same, right? They don't match. Same with false and true, that's not true. And false if and only if false, yep, that works. That's true.